So waves are of three types: mechanical waves, electromagnetic waves, matter waves. Example, I mean, like for mechanical waves, we require a medium. So the example for mechanical waves are sound waves, waves produced through strings. Okay, yeah, we can also take water waves, seismic waves, the waves produced due to tectonic plates, movement of tectonic plates. Okay, these all come under mechanical waves. So for mechanical waves, medium is compulsory, required, it's necessary. Okay, coming to electromagnetic wave, for electromagnetic wave, no medium is required. Without medium, they can travel. Example. So I'll give you example like X-rays, gamma rays, alpha rays, beta rays. Understood? Alpha rays, beta rays, UV rays, microwaves, radio waves, radio waves. These all kind of waves come under electromagnetic wave. All these. Okay, now coming to matter waves. Matter waves are also known as de Broglie waves. Yes. So example, waves produced due to movement of electrons and protons. Okay, so this is the matter. They are the matter present in every material, right? So without electron and proton, we doesn't exist. We doesn't have any matter. So those electrons and protons which are present in a matter, when they move, they produce waves. Such waves are known as de Broglie waves. Got it? So now our chapter waves deals with mechanical waves, especially sound waves. Okay. So where do we see sound waves? We see sound waves generally in medium called air. So no, air acts as a medium for the sound waves. Now, how generally a wave is represented? Okay, a wave is represented like this. So this is called a wave. A wave is that which will see, which will have like this. If you take 1 second, I'll be making it more clear. So here first for wave, what you need to remember is, see, we will have three-dimensional generally x, y, and z. Okay. So here this is called origin. Here we are for sound waves, we will take two-dimensional along x, along x, and along y. The wave will propagate. Uh, Actually, it will be of same height. Okay, now this is called a wave. But for defining wave, what is the definition of a wave? A wave is a disturbance. Disturbance. Where is the disturbance created? In a medium. Yes. So we create a disturbance. So disturbance created in a medium. Now what happens when we disturb in a medium? Generally, if we have, let us take this medium where we have air, there are particles. If you see, particles might be very close or might be very far, like this. Okay. Now let us take the particles. Let us take that they are very like what we call it is, they are at a equilibrium position, means nobody disturbed them. Yes, we call it as equilibrium state or mean state. Now when you take a tuning fork and hit with an hammer, or when you talk, there is a force applied on these particles, right? So these particles which are in equilibrium, generally they are free, means we call it as a rare, they are rarely close. Now due to disturbance, what happened? These particles they move and they come close like this. This is called uh, denser. So what happened here? Particles came to denser, means closer to each other, which we call it as compression. Yes, particles compressed. Here particles are free. As they got disturbed, they are compressed, and these particles which are compressed, again they collide each other and they apply their energy on the other particles, right? Again these particles become free and these particles become compressed, like that, till they lose their energy. These particles, they transfer their energy. Understood? So what will happen? See, rare, they are rare means not close, then they are close, compressed, again they are rare, again they are compressed, again they are rare, and then again compressed. So we get alternately rare fraction, compression, rare fraction, compression, rare fraction, and compression. Understood? Here what happening here in this case, particles are just changing their position and again they are coming back to their own position. So here particles are, see, the particle which is there at this point is not going to the end, only the energy is transferred. What is transferred? Energy is transferred. So in mechanical waves, particles, they just oscillate from their mean position, okay, and they transfer their energy because work is done on them, force is applied, so definitely there will be an energy, so that energy is carried throughout the wave. So here, see, if you take this wave, particles are present here, this particle displays less, more, more, yes or no? See here, this is the height, it is displayed along y direction, this is the height, it has been displaced along y direction. So this is the maximum displacement by a particle, right? Which we call it as amplitude of the wave. What we call it? We call it as amplitude of the wave. Okay. Now this is the point where the particle completes, again comes back to same phase. Means same, yes or no? Where we can see again the same kind of happening along the above x-axis. So from here to here we call it as a one wave, which is called wavelength, length of the wave denoted with the letter lambda. So what is wavelength? It is the distance between two successive rarefactions or two successive compressions. Let us think, this is rarefaction, this is rarefaction, okay, or are you understanding? Here we have like in these waves again we have different types. Instead of compressions, rarefactions, see, this type of wave is produced when we plug the string. This type of wave is produced in the string. This type of wave is produced when we talk. Okay, now, so here we call this one as crust. He, Here when we plug the string, when we plug the string, the vibrations are different compared with when we talk. Force of application is different, right? And we when we take a string, now when you take a string, the vibration particles which are there inside the drum will get vibrated. So particles vibrations is different when we talk and the vibration in the string. That is the reason sound is different. Understood? So no. Here there is a difference. I'll explain the difference. So when we learn the difference, you'll understand. Huh? One second. Done. So here for a string, what will happen? Generally, we are going to tie at the both ends, so it is not free to vibrate for particles which are there in air or in any jar or in a room. so they can able to move, so that compressions and refractions will not happen in this case. Here, how much the vibration, due to that the sound wave will be produced, whether it is a higher pitch or lower pitch. Understanding like this. Sometimes it might be smaller wave. Sometimes it might be bigger wave. Yes. So here frequency will be more. Here frequency will be less, like that. What is meant by frequency? Frequency means number of oscillations in second. Number of oscillations in 1 second. For example, here let us take in 1 second we got one wave, but in 1 second we got around 1.1/4, right? So frequency is more in this case compared with frequency in this. Understood? So yeah, frequency is inversely proportional to the time period. More time, less frequency, less time, more frequency. Frequency is inversely proportional to time. If you are taking more time, what does it mean? It means that the wave which is traveling is taking more time to cross this. Yes or no? The reason is, see, if I take the same, if it is taking more time means more number of waves are going. So frequency is more. Understood? Okay. Now, if you take a sound waves, these sound waves are of two types. One is called stationary wave. Another one is known as progressive wave. Okay. Um, this progressive waves are again two types: longitudinal and transversal. So now you should know what is the difference between progressive wave and stationary wave. Stationary wave is that which are produced between the two fixed points. Means they are going to have a fixed boundary, so that they are stationary. Understood? Now when it comes to progressive waves, they are produced at a point and they go forward and they never comes back. Here the particles which are vibrating, they go to the other end and then again they come back, like this. Example, waves produced in string. Got it? Now coming to progressive waves means the waves which are produced at a point and continues to move forward and they never come back. So how to define longitudinal waves and transversal waves? See, I am explaining here. Let us take, there is a direction for the wave. See, this wave I am representing for direction, not to represent that they are stationary. Okay. So this is the direction. Along x direction, wave is traveling. Okay, now this is the direction of wave. Clear? Are you understanding? Huh. Now see, this is open air, like means room. So some person is speaking from here, this point. Then wave is going in this direction. It is not necessary to represent like that, but we are representing it. The reason is, see, particles, some oscillates like this. Yes or no? See, like this, particles start oscillating generally, and they decrease, and they travel. So when I join them, I'll be getting a waveform. So this is the reason why I am representing it like this, because here also we have particles. Got it? So when a person is speaking here, the wave is traveling forward. These particles, they oscillate in two ways. See here, wave is in this direction, particle is oscillating like this. From here, this is mean position, this is extreme position, this is extreme position. Understood? It is oscillating like this, left and right. where wave is traveling in this direction. So due to the wave, due to the particle, see here there is a particle, here another particle. This particle came here, touched this particle, and again came back. It is not going left and right. It is just oscillating from its mean position. It go here, again come to mean position, again come here, and it oscillates. Uh, this will disturb this particle. Again it will oscillate and comes back to mean position. This particle will disturb another particle and comes back to mean position. Like that, wave will transfer. Okay. Here, how is the particle oscillating? In the direction of the wave. So how they are? It is like parallel, right? Understood? So how we can define a particle oscillating parallel to the direction of the propagation of the wave? In which direction wave is propagating, in that direction, if it is parallelly oscillating, such waves are called longitudinal waves. Understood? See here, in longitudinal, L and L ends with L and L, they are parallel. Clear? Now instead of oscillating like this, the wave is traveling in this direction, but particle, instead of oscillating like this, it is also oscillating up and down. Correct? So how is that? This is the wave direction. This is perpendicular, right? See here, perpendicular. The angle between them is 90. Understood? Wave is traveling forward, and particle is oscillating like this. Means perpendicular to the direction, not parallel. Correct? Yeah, the angle is 90 if I make. Correct? So perpendicular. So if a particle is oscillating perpendicular to the direction of the propagation of wave, such waves are known as transversal waves. So what is a progressive wave? A wave which originates and moves forward and never comes back. Such waves are known as progressive waves. And in those progressive waves, what are longitudinal waves? The waves which originate, the waves which are, the particles which are oscillating parallel to the propagation of the wave. The particles which are oscillating parallel to the propagation of the wave. Such waves are known as longitudinal progressive waves. Longitudinal progressive wave, yes or no? It is a part of progressive wave. So we can also call it as longitudinal progressive wave. In the same way, if the particle is oscillating perpendicular to the direction of the propagation of wave, then we call it as transversal progressive wave. Okay. So if it is oscillating perpendicular like this, then we will have crests and troughs. Okay. If you are oscillating parallel, then we will have compressions and rarefactions. Understood now? What? Crest and trough. Trough. Crest means the point where we get maximum, and trough is minimum. But coming to stationary waves, what will happen here? See, here two waves, they are connecting each other, right? Joining, and we call such uh, joining points as nodes. If we get crest and troughs, then it is transversal. If we get compression and rarefaction, they are longitudinal. If we get nodes and antinodes, this is antinode. This point is called antinode. So this is node, this is antinode. Means two waves join, here no wave will join. Both will be in same phase. Antinode. Nodes are also will be in same phase. Understanding? So are you clear with this? See, node is the point where two waves join. That's connection, interconnection between two waves. Okay now. See, after node, definitely we'll get one antinode. After the antinode, we'll get node. Clear? Yes. So now, this is x direction, this is y direction. Y direction we call it as displacement of the particle. X direction we call it as propagation. Particle will oscillate either like this or like this. Displacement will happen. Yes or no? So if we have a wave like this is the point where displacement is maximum. So the maximum displacement of a particle, the maximum displacement of a particle is known as amplitude of the wave. Is known as amplitude of the wave, denoted with letter A. Okay. Now how to represent equation of propagation, equation of a wave. How to represent the equation of a wave? Okay. So we represent the equation of wave as y is equal to a sine omega t minus kx, or we can also represent as a sine kx minus omega t. Okay. This is one. Another way, y is equal to a sine omega t plus kx, or y is equal to a sine omega minus omega t minus kx. Now see the difference between these two. Let us take whatever this is called phase. Whatever we have inside the angle inside the sine, we call it as phase. Phase is noted with letter pi. Okay. Now you can note. Hmm. 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 So if you first listen, all the doubts will be cleared. First listen the total chapter, then if you have anything, then you can ask me. Okay. Okay. You have to remember this. Now, if I take phase value 0, means omega t minus kx is equal to 0, right? Then what will happen? Kx is equal to omega t. Then what is x? Omega t by k. In the same way, if I take for this one, kx minus omega t as 0, then kx is equal to omega t. From this, x is equal to omega t by k. Both are same, right? In the same way, if you take for this one, omega t plus kx is equal to 0, then kx is equal to omega t minus omega t, right? X is equal to minus omega t by k. Here also you can take minus omega t minus kx is equal to 0. From this, kx is equal to minus omega t, x is equal to minus omega t by k. These both are same. Means these both equations represent same. These both equations represent same. Now what we can understand from this here is x is positive. Here x is negative. Understood? So what is this positive means? This positive means it is in positive x direction. What does negative mean? Negative means the wave is going in negative x direction. Okay. So if both are having opposite sign, kx and omega t both are having opposite sign, then they are positive wave. Propagation is positive direction. If both are having same sign, omega t and kx both are having same sign, then propagation is in negative direction. You have to remember this. Instead of x, we can also have y also. Y indicating that wave is going in y direction. It is not particularly, but here we take as x for our understanding in this chapter. Clear? If both are in opposite sign, means omega t is positive here, kx is negative. Both are opposite, then it will be positive. See here, kx is positive, omega t is negative. Then it is positive. Means wave will propagate in positive direction. If both are in same direction, means same sign, then it will be negative direction along negative x axis. Got the point? One is positive, one is negative, then wave will be positive. If one is negative, both are negative and both are positive, then wave will be positive. These are for bits. Okay, understood now. Hmm. Now we can also take equation. Generally we have this equation like this, right? Y is equal to a sine omega t minus kx. Here, what is meant by omega? Omega is known as angular frequency. Angular frequency. The value of omega is 2 pi f because it is frequency. Okay. T means time. Omega means angular frequency. K. What is meant by K? K is known as wave number. Wave number. How many waves it can produce? Number of waves it can produce. It can explain. This is called wave number. Okay. Na? Omega is nothing but 2 pi f. 2 pi f, which is nothing but angular frequency. See, already you know omega is nothing but 2 pi by t. Studied in first year. 1 by t means, I told you, 1 by t is nothing but f. 1 by f is nothing but t. They are inversely proportional. So in place of 1 by t I can write f. Then it is omega is 2 pi f. Clear? Now, so omega you understood. Now what is k? K is wave number. So k value is nothing but 2 pi by lambda. What is the k value? 2 pi by lambda. Where lambda is nothing but wavelength. Okay now. So what is the unit of wavelength? Meters. And this 2 pi is nothing but unit is radian. So the unit of k value is radian per meter. Very very important units. Okay now. What about unit for omega? Frequency is hertz. Okay now. Hmm. This is 2 pi is nothing but radian. Radian hertz. Now, what is speed of a wave? So generally any wave is traveling, it will travel with some speed, right? Here we represent speed of a wave with letter V. Speed of wave is denoted with letter V. Here we can have two formulas. One is the formula which we use in our childhood. One is the formula which we use this concept. Here we used omega and k. Relation between omega and k with speed of the wave. This is frequency, this is wavelength. So frequency and wavelength together, if it is inbuilt, we will get the velocity of the wave, which is nothing but omega by k. It is the ratio of angular frequency to the wave number. This is one formula. Very very important formula. The other formula, childhood formula, which is nothing but V is equal to F lambda. Remember, V is equal to F lambda. This is called speed. This is called frequency. This is called wavelength. Simply speed is equal to, this is distance. Wavelength means distance. This is nothing but time period. Speed is equal to distance into time. One second, one second. One second. See how we got this formula, I'll explain. This value we can write 2 pi f. K value you can write 2 pi by lambda. From this 2 pi cancel. This will become f lambda. Okay. So we know the distance is equal to speed by time. Distance is nothing but wavelength. Speed is nothing but velocity of the wave. Time period is nothing but t. From that we can write V is equal to sorry, here we wrote formula wrong. Sorry. Distance is called speed into time. So distance is nothing but wavelength, speed is v, time period is t. From this v is nothing but lambda by t. 1 by t is nothing but f. Understood? 1 by t is nothing but f. So both formulas represent same. Both formulas represent same. When f and lambda value you know, you should use this formula. When you know omega value and k value, then you should use this formula. Understood? When to use is important. Clear? Lambda is wavelength. Wavelength. Wavelength is lambda. Clear? 1 by f. Done? So, now let us take pi. Pi is known as, we can write delta pi. Delta pi means phase difference. Delta pi means phase difference. See, if we have one wave, this is a wave. If we have this one wave like this, see the point where it starts is different. Means actually it started from here. So there is a difference in this phase at this point. Understood? Which you call it as phase difference. Delta pi. Sometimes we can represent this phase difference. And here if you take this particle path is not same when I compare this both in one wave like this. Yes or no? So same maximum position if I am taking, this point is not same. So this, there is a path difference, right? Delta x. X point is different for this one and x point is different for this one. There is a difference in the path called delta x. Like maximum displacement. Maximum displacement for this one is, let us take this one as x1, this one is x2. The difference between that two is delta x. So we write delta x is nothing but path difference. The difference in their paths for the same maximum point if you are considering. Now what is the relation between phase difference and path difference? Relation between phase difference and path difference. Okay. Remember this formula, delta pi is equal to 2 pi by lambda into delta x. Delta pi is equal to 2 pi by lambda. This is lambda into delta x. Okay now. So whenever we have problems on them, we can able to do like this by using this. Okay. Now, so what is the equation of a wave? Equation of a wave, y is equal to a sine omega t minus kx, right? Where y is nothing but displacement. Yes, I explained, no? Y is nothing but displacement. Now if I differentiate displacement with respect to this one, time. What is called displacement with respect to time? Displacement by time. Change in displacement by change in time. Rate of change of displacement is known as, what is the rate of change of displacement? Velocity. Speed or velocity? Here displacement. Displacement is a vector quantity, therefore we will have velocity. So now if I differentiate this, I will get velocity. Let us differentiate. D by dt into a sine omega t minus kx, right? From this, when I am differentiating, A will come outside because amplitude is fixed. D by dt of sine omega t minus kx. What is d by dx of sine x? That is equal to cos x. Therefore, it will become A. This whole thing will become cos omega t minus kx. And before t, omega is there, so omega will come outside. Then what happens to this formula? A omega, velocity is nothing but A omega cos omega t minus kx. Velocity is A omega cos omega t minus kx. T minus ks. In terms of equation, we should use this. In terms of formula, I explained before. Velocity. Understood? Now, if this huh, distance is lambda, A is amplitude. A is amplitude, maximum displacement. Okay, now here, so differentiation. You are MPC student? By PC. Okay. Hmm. Okay, fine. So see here, d by dx of sin x is cos x. D by dx of cos x is minus sin x. Remember this formula. You can write it down whenever whatever I'm explaining, you can write it down and you can learn. Now look here. Here what I'm doing, this is displacement. Y is nothing but displacement of a particle. Displacement by time in physics we have a term called velocity. Speed is distance by time. Velocity is displacement by time. So if I am doing displacement means change in velocity by change in time, then change in displacement by change in time, then I will get velocity. This change we can represent with d. Difference. Change means difference. Differentiation dy by dt. If I do this whole equation, differentiation with respect to time, then my equation will become d by dt into a sin omega t. In place of y I am writing this whole equation. A is constant because it is a maximum displacement. Maximum displacement here it remains same. Peak values. So for constants we will not do differentiation. So A will come outside. Okay, now d by dt sine omega t minus kx. So when I am doing differentiation for sine, first when I am doing for sine, see here x means this whole thing. So whole thing I am writing as cos. A is outside. So these two I am writing. Next, before t any coefficient is there because we are differentiating with respect to t. So you should look at t. For t any coefficient is there, that coefficient also will come outside. We are not doing for x, therefore we are not taking any k or x outside. Understood? So now if I do the same differentiation now with respect to x, not with respect to time. If I do the same differentiation with respect to x, then what will happen? Velocity will become d by dx of a sin omega t minus kx. Here as usual a will come outside. D by dt of sin omega t minus kx. Now sin will become cos. Yes or no? Sin will become cos, so it will become cos omega t minus kx. Now I am doing with respect to x. So before x what I have? Minus k. So I will write that minus k here, minus k. Understood now? Minus k minus ak cos omega t minus kx. If I do differentiation with respect to x, clear? This one we call it as velocity of the particle, not the wave. This is for particle velocity. This one is for particles velocity. Okay, now how much particle, because it is displacing, no, displacement, that is for particle, not for wave. For wave it is v is equal to f lambda. That is for wave, velocity of a wave, that is. This is velocity of the particle. Understood now? Clear? Hmm. So you have to write and you have to read again, then you will be feeling it more better. I hope these all things are been not explained in your college. Yes, kind of. Relation between velocity of the particle, we have taken velocity of the particle, right? Relation between velocity of particle and velocity of the wave. So formula is Vp is equal to velocity of the particle is equal to minus velocity of the wave into slope of the wave. This is the formula you can remember. What's the relation between velocity of the particle and velocity of the wave? Velocity of the particle is equal to negative sign of velocity of the wave into slope of the wave. If I take an example, so this is a wave. If I take any particle is here, let us take this particle is A. Now slope is like this. So, to get slope I should draw a tangent. So when tangent is parallel to x-axis, slope is 0. Slope is 0. Therefore particle will go in same direction. If I take this particle here, now if I draw a tangent, tangent is downward. So slope is negative. Correct? Because downward, no. If I take this side, slope is positive, upward. Here when slope is negative, minus into minus becomes plus. Understood? So particle B will be moving in positive direction. Particle A will be moving in negative direction. And particle, this one, particle here, let us take C. Because positive, no? Are you understanding? Here, particle B is there, its slope is negative. If I put negative in place of slope, minus into minus is plus. Then particle B will be moving in positive direction in the next phase. If I take C, slope is upward, means it is positive. If I put this one positive, this one negative, total product is product, because product is negative, right? Means in the next stage, the C particle will come down. Okay, now next phase, what is the direction of the particle? That can be known by using this. But what about A? A will be in the same place because slope is 0. It will not change. Understood? Okay, shall we do one or two numericals? Okay. You just give your number. I will send the recorded video. Or you can go to my YouTube channel and you can watch the same video. Sure. 9346. I'll write here. You just message. I'll send you the recorded video. Done. So now come to this question number 1. Problem numerical 1. See, I'm not giving you total question. I'm just giving you the glance. Y is equal to a sine 628t minus 31.4x. Y is equal to a sine 628t minus 31.4x. Okay. Find the uh, calculate calculate wave velocity or velocity of the wave. Calculate the velocity of the wave. What formula you can use? Velocity of wave velocity, not particle velocity. So velocity of wave is equal to omega by k, or you can use velocity of the particle is equal to f into lambda. Okay, now so how to know this? First you should write this in general equation form. What is the general equation form of wave? Y is equal to a sine omega t minus kx. So here a is a, no change. Omega value is 628. K value is 31.4. Here this is positive, this is negative. Yes or no? This is positive, this is negative. If they ask you what is the direction of the propagation of the wave, direction is, if one is positive, one is negative, direction will be positive. Given x, so it is positive x axis direction. So now for this, we should not use this formula. We already know omega value and k value. Directly we can substitute here and we will get V as 628 by 31.4. Now you can write this one as 628 into 10 by 314. 314 two times. 2 into 10, 20. Velocity, yes or no? 20. Velocity is nothing but, if they give you in meters, these all values they give you in meters, then it is meter per second. If they give you in centimeters, then your answer will be centimeter per second, depending on the units they give this. Okay. Second numerical, y is equal to 0.05 sine of 8x minus 4t in meters. This one explains that it is in meters. Okay. Find the velocity of the wave. So how to do? Same formula. So V is equal to omega by k. Solvental. Yes. This is plus k value, that is equal to 8. This is minus omega value. Omega value is minus 4. Okay, here we will not take for solving values, we will not take plus and minus. Only for direction we will take that. The plus and minus indicates only for direction. For solving this, we will not take minus or plus, we will just directly take plus and minus. So, what is the answer? 4 by 8. 1 by 2. That is equal to 0.5 meter per second. Understood? Yes. That's it. So, you can solve. Shall I give one more question? So, question number 3. Third model. See, the distance between the distance between two consecutive points, the distance between two consecutive points with phase difference with phase difference is 60 degrees in a wave of frequency 500 hertz is 6 meters. Find the Okay, find the velocity of the wave. Find the velocity of the wave. Here, distance between two consecutive points is 6 meters. Phase difference is 60. Frequency is 500 Hz. They are asking. So here, distance between two consecutive is nothing but delta x. Path difference. Distance between two points, delta x. Path difference. We call this one as path difference. Instead of using the word path difference, they use the word distance between the points for the wave. Okay. So frequency f is equal to 500. Here phase difference. Phase difference means delta pi. That is equal to 60 degrees. This should be in radians, but they gave in degrees. That should be in radians, but they gave in degrees. So let us convert. How to convert? Okay. See here. We have to write 180. Sorry. We have to write here 2 pi by theta, where theta is in degrees. Then it will become in radians. So 2 pi by theta value is 60 degrees. Here, or simply I'll explain. Wait, instead of taking like this, don't get confused here. We can write 60 degrees as 180 by 30, right? 180 is 180 by 30. If you write, it is 60 degrees. 180 by 3. Sorry, 180 by 3 is 60 degrees. Okay, now this 180 is nothing but pi. Pi by 3. 60 degrees we can write it as pi by 3. 60 degrees we can write it as pi by 3. So this formula will become. So we know all these things. What is the formula? Delta pi is equal to 2 pi by lambda into delta x. So in this, what we need to find? Velocity of the wave. Here we don't know lambda. Why we need lambda? Because we know that v is equal to f into lambda. We have f value. We don't have lambda. So to find lambda, we should use this formula. That is equal to 2. 1 second. That is this implies pi by 3 is equal to 2 pi by lambda into 6. Okay, now pi cancel. Lambda will come this side. Lambda is equal to 6 3s are 18, 18 2s are 36. Correct? This lambda will come here. 3 will go this side. 6 into 2 into 3 is 18 meters. 36 meters. 6 2s are 12. 12 3s are 36. So here we can write 500 into 36. 500 into 36 is 1800. See, 5 6 are 30, 0. Already 2 zeros are there. 5 6 30, 0 3. 15 plus 3, 18. 18,000 meters per second. Or we can also write this one as 18 kilometer per second. Done? Okay, that's it. This is the way how you need to solve this. This is part 1 of waves. And in the next class we will continue with the next part. Okay? So please read this. Sure, definitely. Definitely. Okay?